Simulating Sinkhole attack on IoT nodes running Ripple protocol. My name is Faisal A. Garba and I'm a PhD student. I'm currently working on resolving routing attacks on this particular Ripple protocol. So in this lecture video tutorial series, we are going to take a look at how to simulate Sinkhole attack on IoT nodes running the Ripple protocol. Now let's try to understand what is a sinkhole attack first. So sinkhole attack is another variant of isolation attack like the black hole attack. In the previous video, we have seen how to simulate a black hole attack. Now, this sinkhole attack is very much similar to the sinkhole attack, a black hole attack rather. So sinkhole attack Ripple is actually a combination of two types of attack: rank decrease attack and a black hole attack. Now, a rank decrease attack is a situation whereby a malicious malicious node will lower its rank so as to make itself attractive to the other node to be selected as a preferred parent. So because many, according to the Ripple protocol, many nodes will prefer a node that has a much more lower rank than them as their preferred parent, because they guarantee that will guarantee that the packet they transfer to that parent node will eventually reach the root node. Now, when neighbor node have selected that malicious node that have lower its rank, then they have selected as their preferred parent, and then they become their children, then it will start dropping their packet. So first of all, decrease the rank to make itself attractive to neighbor node to be selected as their parent, and then next it will execute the black hole attack by dropping any packet that the children node transfer to it, relate to it for propagation to the root node. So rank decrease attack. To implement the rank decrease attack, some changes are necessary to the normal source code for the Ripple implementation in Kentucky. Now the files to be modified and the directory Kentucky/code/net/Ripple. And these are the two files, rippleprivate.h and rippletimers.c. Now this rippleprivate.h, that this particular file contains private declaration for the Kentucky Ripple implementation, such as the default values for the Internet Control Message Protocol control messages and timers associated with them, their mode of operation, and the DAG routing tables. While the rippletimers.c is a file, is a C source code file, which is the Ripple, which contains implementation of the Ripple timer management in Kentucky. Now, the changes to perform to carry out to the rippleprivate.h. Now, in the rippleprivate.h, it contains various constant definition related to the directed acyclic graph rank calculation. So the decrease rank attack can be implemented by altering some of these constants so as to interfere with the safeguards that are included in the rank computation algorithm. So as we can see in line number 120, that is where we perform a change. We added that particular preprocessor directive #define Ripple conf minimum half rank increase to 0. We change it to 0. We set it to 0. And then in line number 125, we change that particular directive #define Ripple maximum rank increase. Initially it was 7 times Ripple minimum half rank increase, and then we set the value of that particular macro to 0. Also in line number 136, we have the macro #define infinite rank. We set the value to from that particular hexadecimal value, we change it to 256. Next, we move to the rippletimers.c. Now, this is a file that contains code that calculates the node rank used in Ripple. So, this implementation of the decrease rank attack also requires to disable this calculation so that the effect of the rank decrease are not undone. So, and in effect, what we did here is that we removed that particular line number 70, Ripple calculate ranks. So, we remove it by just commenting it out, as we can see it in line number 70. Now, next to implement the black hole attack, though we have already covered this in the previous video, but since it is necessary for sinkhole attack, we cover it here again. Then we need to perform changes to a particular file which is located in this particular directory, config/co/net/ip version 6. Now there is a particular file called microip6.c. Now this particular file contains the code that forward packet not intended for the current node to their destination. To implement the black hole attack, malicious nodes should drop all such packets. So, and this will in effect cause create the black hole attack scenario. So we have in line number 1240, we have the micro IP start. We have that particular variable, we increment it. So initially it is micro IP start.ip.forwarded, as you can see in that particular comment. Then we change it, we change the from forwarded, we change it to drop. And also in line 1241, from go to send, we change it to go to drop. So this in effect will also create the black hole attack. So now the next thing we are going to do, we are going to move to the Contiki operating system, and then we are going to launch the Kuja simulator, and then we carry out the simulation. So let's move to Contiki operating system. So this is my Contiki. I'm going to log in. Let me close this. Okay, so now I'm going to launch my terminal. I have a terminal terminator. So I can zoom it a little. Zoom terminal. Alright, so now I'm going to navigate to the Contiki directory, cd Contiki 3.0, and that Contiki tools Kuja simulator. Then let me clear the screen. Then I need to launch the Kuja by entering this command sudo and run, and then I'm going to enter my password. Okay, I entered the wrong password. Let me re-enter it again. User. So this will launch the Kuja simulator. We have the Kuja simulator. Now we want to perform the simulations. So what I'm going to do, I'll just come on that file here. New simulation. My simulation. So I'm going to, let me call it attack, or let me call it just Sinkhole. Sinkhole. And then I'm going to create. Now you can see that the simulation environment has been launched. Now we want to add modes. Come here, add mode, create new mode type, and then we'll say sky mode. And then I'm going to browse to the right directory. So here Contiki 3.0, and I'm going to go under examples, and then go under IP version 6, and then I'm going to go to RPL collect, and then I'm going to select the sync, that is the root node. I'm going to compile it. I'm going to create. So just one is okay. Add modes 1. I can come here, and so that I can be able to differentiate between the different mode types. Mode type. Now next, I'm going to add the routers, that is the nodes, the source nodes that are going to be in the network. So I'm going to go over again, modes, add modes, and select create new mode type. I'm going to go for sky mode. I'm going to browse, and this time around I'm going to select udp sender.c. Open. I'm going to compile it. I'm going to create. Then I'm going to add 11 modes. Add modes. Now these are all normal modes within this particular. Let me just rearrange them here. I'm going to have node. Where is my node 11 here? I'm going to bring it here. Let me drop it here. Then we have node number 12. I'm going to have my 12 here. node 10, 10, 11, 12. So I want this node to be these three modes. I want them to be within the transmission range of the sync node, so that all other node that we want to reach out to the root node will have to select one of these nodes as their parent. So I'll come over here. I will now put these nodes on this particular place. I'll just rearrange them. We drop one here. I will drop also one here. I'll have another one. I'll drop it here. Another one. I'll drop it here. Another one. I'll drop it here. And another one. I'll also drop it. Okay. I'll drop it here. Okay, so let me click a second. No, I don't want them to be within the transmission range of the root node, so I'll move them off a little. Move this one off, move this one up. So when I click on this, now they are some are still within the transmission range of the root node. So when I click on it, you can see that they are outside the transmission range of the root node. But are they within the transmission range of this node? And some are not. So let me move some of these ones off a little. Off here. Also. So for any of the other modes that want to reach out to the root node, they have to select either node 10, node 11, or node 12 as their parent, and then for them to be able to reach out to this particular root node. So when we start the simulation, this will serve as parent any of these modes 2, 3, 8, 7, 6, 9, 4, 5. We'll have to select one of these modes to serve as its parent for them to reach out to this particular root node. That is what is going to happen. Just and following the normal parent selection process in the Ripple protocol. So that is what is going to happen. So now let's simulate this under a normal scenario, that is a normal Ripple network scenario without introducing any attacking node, and then observe the effect, observe the result, and then next we launch the attack and then see the difference between a normal Ripple network and then Ripple network under a Sinkhole attacking node. So, but for me to be able to observe the behavior of the mode under normal scenario and under attack scenario, I have to make use of a tool called collect view. So I'm going to this particular root node. I'm going to right click on this, select mode tools for sky. I'm going to select collect view. Okay, this application has launched. I'm going to click on start collect. Next I'm going to click on send command to node. Okay, so next now I'm going to start my simulation. So let me just maximize this here like this, and then next I'm going to click on start simulation. So I'm going to run this simulation for 10 minutes or thereabout. Okay, let's say 7 minutes. Let's launch it for 7 minutes, and then we'll come over and observe the result of this simulation. So let me run it. So I will pause the video, and then after 7 minutes I'm going to resume and then see the results that we have. The result that is the behavior of the node that we have been able to capture using the collect view tool. Alright, so I'm going to pause the simulation now. Let's pause it, and then let's go to the collect view and then see the data we have been able to gather about the modes. So I'm going to see the power consumption of the mode. So we can see that all the modes have been reflected in this particular power consumption graph. We're starting from mode 2, from the root node, the mode 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of them have been presented in the network. That means there is no any malicious attacking node carrying out attack on this particular mode. So what I'm going to next, I'm going to introduce the malicious attacking mode to this particular RPL network. So let me close the collect view. Okay, so let me just off here. Let me close this one. This is part of the collect view. So I'm going to reload the simulation, and then I'm going over there. I'm going to remove one of these modes. Let me remove this mode, either mode 10 or 11 or 12. Well, let me remove this mode 11 or mode 12. Let me remove mode 12, and then I'm going to introduce the malicious sinkhole attacking mode. So I'll just come up here, mode, add mode, and then create new mode type. I'll go for sky mode, and then I'm going to browse, and then I'm going to go to that particular sinkhole where I created the sinkhole attack in the instance of Contiki. So I have it here, sinkhole. So basically what I did is that let me explain how I did my how I created the simulation for the file for the sinkhole attack. Since I have Contiki 3.0, what I did, I just duplicated this Contiki 3.0 folder, and then I renamed it to sinkhole, and then inside I went to the particular files that we have explained in the theoretical aspect, and then I made the necessary modification for the sinkhole attack. So that is just basically what I did. So you can execute the same, and I'm also going to be dropping link to the files so that you can just download the files and then replace them inside the sinkhole directory that you have created. That is the Contiki 3.0 directory that you have duplicated are the name to sinkhole, and then you change the files, you swap the files with the files that I'm going to provide for you, and then you also be able to replicate this simulation. So let me go back. I'll just go to mode, add mode, create new mode type. I'll go for sky mode. I'm going to browse to the sinkhole folder. So sinkhole, I'm going to select sinkhole here, and then I'm going under examples. I'm going under IP version 6, and then RPL collect. Then I'm going to select UDP sender.c. So UDP sender.c, I'm going to open it. I'm going to compile it. I'm going to create just one, add mode, and then I'll make sure I maintain just same particular topology that I had previously. So let me just zoom in, increase the zoom. That's how it was before. Zoom in, so that we can see it more clearly. So let me just bring the mode here where mode 12 was before. So here it is. Now you can see all these modes, these other modes can be able to select 12 as their parent. They can also choose to select 11. They can also choose to select 10 as their parents to reach out to this root node, since their aim is to have their packet transferred to the root node so that it will be related to the traditional internet. Okay, so now I'm going to click on this root node, mod tools for Sky 1, and then I'll go under collect view, and then I'll click on start collect, and then I'm going to send command to mode. Then I'm going to go over and start my simulation. So let me reduce this, and then now I'm going to start simulation. So we are going to wait for the simulation for 7 minutes, and then we'll come over and observe the result of the simulation, just like we did in the normal scenario without any attacking modes. So I'll pause the video, wait 7 minutes, I'll come back, and then we are going to see the results of the simulation. Alright, so 7 minutes has elapsed. I'm going to stop the video, the simulation now. Let me pause the simulation, and then now we go and see the results we have been able to gather using our collect view. Power. So as we can see, these are the modes that have been presented in the collect view. We have mode 10, 11, 2, and 12. So let me enter them here. Yeah, instantaneous power, still power history. So power, radio duty cycle, average power. So these are the only mode 2, 10, and 11, 2, 12, 2, 10, 2, 10, 11, and 12, 2, 10, 11, and 2, 10, and 11. So these are the modes that have been presented in the network. Let me increase the size here. So 2, 10, 2, 12, 10, and 11. 2, 12, 10, and 11. So we can see normally, since we are there at the same level with the malicious mode, so we won't expect any of them to select malicious mode as their parent. So they have been reflected in the net in the power consumption. They are part of the network. None of them have been isolated. We can see 10, 11, 12 is there, and also mode 2. So mode 2 decided not to select the malicious mode as its parent, even though it has advertised a lower rank. But all the other modes have been deceived into selecting mode 12 as their parent, and since mode 12 is a malicious sinkhole attacking mode, it dropped their packet. Their packet couldn't reach the root node. That is why they have not been reflected in that particular collect view. We have not been able to see their power consumption behavior because they have not been reflected. They have not been represented in this particular network. So that is why we couldn't see them. We couldn't see them in we couldn't see their power consumption. That's why their power consumption has not been presented. So this is the effect of a sinkhole attack. Sinkhole attack is a combination of black hole attack and a rank decrease attack. So mode 12 decrease its rank so as to attract other modes. So the other modes, they could have selected 11 because all of them could they are within the transmission range of 11, and all of them they are within the transmission range of node 10 with the exception of 7, but they decided to select mode 12 with the exception of 2. They all decide to select mode 12 because it has advertised a lower rank, and mode 12 is unfortunately a malicious mode, and it dropped their packet. That is why they have been isolated from the network. So that is the worst effect of this particular sinkhole attack. Sinkhole attack is basically a combination of both a black hole attack and a rank decrease attack. So thank you very much for watching this tutorial, and please subscribe to my channel. Thank you.